Let us discuss about the surface energy. We know that due to the surface tension, the free surface of a liquid tends to have the minimum possible area. So if we have to increase the surface area of a liquid at rest, we have to work against the surface tension, and that work done against the surface tension is stored in the liquid film or the liquid free surface as its potential energy, and that potential energy is called as surface energy. So we can define the surface energy as the work done against the surface tension in order to increase the surface area of the film. Now, how do we calculate the surface energy? We take a frame A, B, C, D with a movable side P, Q. We dip the frame in a soap solution. That means we have got two surfaces of the soap film in contact with the air, one on this side and one on the inner side. So, the forces of surface tension act tangentially to the sides on both the films. That is, here it is inverse, 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 but tangentially. It acts tangentially as to decrease surface area of the film. Now, if we pull this sliding side PQ by a force F to this side, to the right side, and increase its length by X, we have increased the area on both the sides. That means there is change in area, but that change in area is twice the length into X. We can have the change in area as delta A, that is equal to P dash Q, and that is equal to 2L into X, because we have got two surfaces, one on the outer side and one on the inner side. So the change in area is twice L into X, that is L into X of the front side and L into X of the back side. So the change in area is twice L into X. Now, as we have got two surfaces, the surface tension, let surface tension be S. Now the force is surface tension into the length, and the length of the two surfaces whose area needs to be increased is 2L. We know that the surface tension is force into length, but here we have got 2L, not L, because we have got two surfaces, one on the outer side and one on the inner side. Now the work done is force into distance. The force is equal to S into 2L, and what is the distance by which this sliding side PQ is pulled is X. So W is equal to S into 2L into X. Now, as already discussed, 2L into X is the change in area. So the work done is equal to S into delta A, that is change in area. Now this work done is stored in the film as its potential energy, and that potential energy is called as surface energy. So we have that this work done is equal to the surface energy, that is equal to W, that is equal to S into delta A, where S is the surface tension and delta A is the change in area of the film. The surface energy is equal to surface tension into the change in area. Now from here, the surface tension equals to surface energy divided by change in area. So here we can define, we have already one definition for the surface tension, that is force per unit length. We have here got another definition from the surface energy, that is the surface tension can be defined as the ratio of surface energy to the change in area. As the energy and the area are both the scalar quantities, that means the surface tension is a scalar quantity. If the change in area delta 1 is 1 units, if the change in area is 1 units, in that case S, the surface tension, is equal to the surface energy. So we can say that the surface tension is numerically equal to the surface energy of a film whose area has changed by 1 units. The surface tension and energy have got different units, but their numerical value can be same. So I will repeat, the surface tension is numerically equal to the surface energy of a film whose area has increased by 1 unit. 1 unit is 1 meter square. The surface energy is the increase in potential energy which has got by increasing the area of the film as work is done against the surface tension, but at a particular temperature. This is important. The temperature needs to be constant. Thank you.